In this video, we're going to create an EKS cluster from scratch using Terraform. And we'll be doing it using Terraform best practices like S3 bucket as a backend and variable interpolation. This is the architectural diagram for this exercise. And we'll be using 3 Terraform modules. First is the VPC module to create our beautiful networking resources. We'll have 3 availability zones. We'll have 3 tier subnets, public, private, and intra subnets. The second module will be the KMS module. We'll be using the KMS to encrypt the worker node volumes. And lastly, the third Terraform module is the EKS module. So we'll be creating an EKS cluster. We'll be spinning up the worker nodes in the private subnet, and then we'll be spinning up the control plane interface in the intra subnets. Let's go. Okay, we're gonna set up the IAM user that we're going to use to interact with the AWS account. If you got this set up, please just skip through. If not, just follow through. I'm gonna go to IAM and then users, create a user. Let's name the user Terraform, and it doesn't need console access, so I'm gonna skip that part. Hit next, and then I am gonna attach policies directly, and let's just attach admin access. I'm gonna hit that, next, and I'm going to create that user. Once that user is created, let's go inside, and under the security credentials, let's create access key. So CLI, I understand, next, and then I'm gonna hit create access key. And I am going to, well, best practice is to download the CSV file, so let's do that. But I'm gonna leave this screen for now. Let's go ahead and set up our AWS CLI. I'm gonna bring up the terminal, and a prerequisite is to have AWS CLI installed in your terminal. Let's do a quick check by doing AWS --version. It should have an output similar to mine. Maybe you'll have a different version. And then let's set up the AWS CLI by doing AWS configure. And it's gonna ask for the access key ID, which is here. And then secret access key here. Please don't copy out my access key and secret access key, because I am going to delete these once this exercise is over. Default region, now this depends where you are. Since I am in Australia, I am gonna choose AP Southeast 2, which is Asia Pacific Southeast 2, which is in Sydney. And then output format is JSON, since I'm quite familiar with that format. All right, and then we're gonna do a quick test. AWS SDS get caller identity, and it should show the user that we just created. And voila, user Terraform. All right, now we're good to go. I am going to use Visual Studio Code. You can choose whichever IDE you're comfortable with. And I've created a blank folder called AWS EKS. This will be the folder that will have our Terraform code. Now let's create a folder called state bucket, and this will create the S3 bucket that will store our Terraform state files. And under state bucket, let's create a file called main.tf. We're also going to create 2 additional files called variables.tf and terraform.tf-vars, which are required if we want to use interpolation. Now that's sorted, let's go back to the main.tf. And in main.tf, we have several sections. You can put it as different files, but I like to keep it simple, and I like to have just different sections under my main.tf. And I like to use comments just to keep it organized. So for example, I'm going to create a provider section, and that's how I'd do it, is I'd have a provider header in here and then the provider code afterwards. So let's go back to Chrome or whichever is your internet browser, and let's do AWS provider. Go there, and I am just gonna copy out these and paste it there. And this is where variable interpolation comes in, because I can reuse this code in a different region just by substituting this with var.region. And then we're gonna declare this variable in the variables.tf. Now let's go back to Chrome and search for Terraform variables. And we're just gonna copy this bit. And then let's go to variables.tf and paste it here. But on top, let's do the comments. And this is, I want to put in variables for environment. And which variable was that? Region. I'm just going to replace that. And the type is string. And we want to have AP Southeast 2, at least for me. You can add in description here as well. AWS region. And yep, that's all good. Another variable that we want to use is the AWS account ID. Type is also string, but this one we won't have any default, so that will be required. And then description will be AWS account ID. Let's add another variable called environment. Description will be name of the environment. And then let's copy the default in here and put in as dev as default. There you go. And now to use Terraform.tf vars, it's primarily used for variable definitions. So for example, I want to overwrite, or I want to not use the default. Instead, for let's say for region, the default is AP Southeast 2. But for this particular use case, I want to spin up the resources in US East 1. So what I can do is, again, let's copy these out. And environment. I think we're in region, and instead of using AP Southeast 2, I want to use US East 1. And for the account ID, since this doesn't have any default value, we need to have this filled up. So in here, let's go back to my AWS account, and I'm going to copy out my account ID. And I'm going to paste it there. And then the last variable is the environment variable. And let's say, hey, I don't really want to use dev. I want to use maybe stage, something like that. And let's just this standardized. There you go. So we've got 3 variables and then 3 variable definitions. And the region and the environment, these are not required. Only AWS account ID is required because it doesn't have a default value. Okay, let's proceed with the main.tf. So we've got the region here interpolated. So this will get US East 1. Now our goal here is to create an S3 bucket that will hold our state file. Let's just create a header. And let's go back to the official Terraform documentation. Let's search for S3 Terraform, and let's copy out this one and paste it over here. Right off the bat, we can change the resource name, and I want to have a name that relates to the purpose of that resource. So in our case, it's going to be state. And then for the bucket name, this needs to be unique for all S3 buckets. And what I like to do is to prefix this with my account ID, because we already have that in our values. So AWS account ID, let's copy this and paste it here. And then bucket state file. So that will be the name of the S3 bucket. It will be my account ID, bucket state file. And then for the tags, I don't really need the name. And for the environment, we also have that as a variable. And there you go. So let me just change this to var environment. And that should do it. Now let's go to terminal. I'm gonna do new terminal, and I am in the AWS EKS folder. Let's cd to the state bucket and then do a Terraform init. All right, it took a bit of time. Oops, I accidentally closed the terminal. Let's open up a new one and let's go back to state bucket. And I just did the Terraform init. Now let's do a Terraform plan. And it should show that we are intending to create one S3 bucket. There you go, one to add. And then let's do a Terraform apply. And I'm gonna do auto approve because I already know what it wants to create. It's creating and apply complete. Let's go back to AWS and let's search for S3. Right there. So that's the AWS account ID, which is the same as this. And then bucket state file, and then it is in US East 1. And that's ready to use. Now let's just go back real quick to Visual Studio Code. And if you can see here, it created the terraform.tf state in my local folder. This will not be the case when we create the EKS cluster. The terraform.tf state file for the EKS cluster will be stored in here. So it will be remotely stored and it can be accessed by other team members. Let's go back to the Visual Studio Code. And in the same repo, I'm just going to create a new folder called Terraform. And I'm just going to copy out the files from here. We don't need that. In the main.tf, in the Terraform provider block, we can just reuse this code, but we need to add the backend. And to get that, let's search for S3 backend Terraform. And then we're just going to copy out this bit here. All right. And let's just replace that with our actual values. Let's go to S3 bucket. I'm just going to copy this one. And the key, you can use any key that you like. I normally do Terraform, and depending on the use case, so for example, EKS and then TF state. And then the region, I think this is in US East 1. So that's done. And we don't need an S3 bucket. I'm going to replace this with VPC. And I'm just going to remove this. And yeah, we can start from here. So for the VPC, we're going to be creating the network resources using the VPC module. To do that, let's go to the VPC module and Terraform. And what we're going to do is first, let's copy this one. This is needed. You need to pin your version, otherwise it can break. And that's the latest as of August of 2024. And then for the usage, let's just copy this one. Source, and let's paste it there. Cool. We still have the 3 variables and 3 variable definitions in here. Let's add a new variable and let's call it application, and the variable app name, which will be a string. Description will be name of the application, and default, you can create your own. Let's do EKS cluster or EKS exercise. Again, if you want to override EKS exercise, you can just go to terraform.vars and just override it here. I don't want to use EKS exercise, let's say. I want to use random app, something like that. And let's create a header. Let's make it tidy. And then we'll be using random app as a prefix for our resources. Okay, so version is 5.13. Name is I want to use the random app. So to do that, I'm just gonna interpolate var.app underscore name -vpc. Availability zones, because we're not in EU West 1A, we are in US East 1, I think. Yep. Region. And I can just do that. So what this will do is it will replace EU West 1 with US East 1. Private subnets, we need that. Public subnets, we need that as well. And we're going to add in a new input, which is called intra subnets. So for the intra subnets, we'll be using this for the control plane interface for the EKS cluster. There, so 1, 102, 103, we can use 104, 105, and 106. So you can use your own values in here. You don't have to follow this one. This is just for an example. And then enable NAT gateway true. So that means that the resources in the private subnet will have internet access. And then VPN, nope, we don't need that. So I'm just gonna remove that. And since this is just for a demo, I want to reduce the cost and I want to enable, or I want to just have a single NAT gateway, single NAT gateway, there you go. So we enable the NAT gateway and single NAT gateway is equal to true. Copy these. Single NAT gateway is equal to true, and then one NAT gateway per AZ is equal to false. Because by default, the VPC module, if the NAT gateway is enabled, it will create a NAT gateway on each availability zone that you put here. So in our case, it will try to create 3, but we've set that to false, so it will just create 1. That's good. Tags, we got Terraform is equal to true. And I believe we have a variable called environment already, so we're gonna use that. Type this up. And a requirement for EKS is to have proper tags in your public subnet and in the private subnets. So this will allow the EKS cluster to know where to put the public ELB and where to put the internal ELB. For that, let's go back to the documentation again. And I think it is private subnet tags. Yeah, there you go. Private subnet tags. So we're gonna use that. And then we're going to input this value. And same goes with the public subnet tags. Let's create those. So let's just copy paste and public subnet tags. And this will be internal ELB. Okay, that looks good. Let's try this out. I'm going to terminal AWS EKS. I am headed to Terraform. And then I'm going to do a Terraform init. So this should initialize the S3 backend. Yep, that's good. And it will download the VPC files in here under the Terraform modules and then VPC. Okay, it's been initialized, and let's do a Terraform plan. Let's see how many resources this VPC module will create. All right, so it's going to create 30 resources, and let's do a Terraform apply. All right, that's done. Took approximately like 3 to 5 minutes. Let's double check. Let's go back to the AWS console in here. Go to VPC and just ensure that you're in the right region. In this exercise, it's North Virginia, which is so far from me. Let's go VPC. There you go. Random app VPC. Let's check out the subnets. We're expecting 9. Yep. 9 subnets. Why 9? Because there's 3 tiers. So we've got the private subnets, we got the public subnets, and then we got the intra subnets. And each of those tiers or layers, they have 3 availability zones. So for example, intra has 1A, 1B, and 1C. Private, same thing. Public, same thing. Now that the VPC is sorted, we can now create the KMS keys that we'll use to encrypt the volumes for the worker nodes and the volumes for the secret resources that you might have for your EKS cluster. To do that, let's search for the KMS module Terraform. Let's copy out this one so we can pin the latest version, which is 3.1.0. I'm just going to close it for now. And I am going to put it under VPC. This out and create a beautiful header for the KMS. Awesome. Next, let's copy out the actual code. All right. For the description, I usually put how I'm intending to use this KMS key. So in our case, it's going to be EKS cluster. Key usage, I'm going to leave that as encrypt decrypt. As for policies, we're going to create a new resource called data. And to do that, let's just grab a header and call this data and then paste this. So what this does is it's gonna get the AWS caller identity, the current one, which is myself. And with that, we can play around. Like, for example, I can get the ARN of my user, of my current user. And then to use this resource, I'm just gonna go and replace this with data.aws caller identity .current and ARN. And I want to add in another input called key owner, just in case you have a use case for this one where the key administrator is different from the key owner. Let's grab this here. But in our case, it's going to be the same. And for the key service roles for autoscaling, we need this entry as well, because we'll be using the KMS key to spin up new volumes for, let's say, new instances if we're scaling the EKS cluster. And for this one, we are going to just change this bit here with var.aws account ID, which is a variable definition that we have under Terraform.tfrs. There we go. Let's go back in here. For this bit, you need to have this enabled first. Okay, do that. Just search for service link roles and then just follow in these steps. I've already done it, so I'm not going to show it here, but this is what you need to do. Otherwise, this step will fail for you. Okay, going back, aliases, usually put EKS in here, and then the var app name, so it will be EKS/random app. For the tags, Terraform is equal to true, and then environment, I believe we have an environment variable as well, and that should do it. Let's try this out. Let's go to terminal, and let's go to Terraform. And since this is a new module, we need to run Terraform init again so that it can download the module files in this directory. Once this is done, yep, there you go, KMS. And then let's do a Terraform plan. All right, it's going to add 2 new resources. And then let's do a Terraform apply, auto approve. Okay, apply complete. Let's double check. Let's go to KMS. And I'm in the right region. Let's go to customer managed keys. And there you go. That's the KMS key that we just created. Okay, so we're at the last part where we're going to create the EKS cluster itself. Let's go and reuse this tab to EKS Terraform module. And I'm just going to copy out the this one. And let's close this one. Let's close this terminal. Under KMS, I'm just gonna put that there. And I'm gonna create its own header. Yes. We're going to be using 20.23.0, which is the latest as of August 2024. And then let's copy out this sample code in here. Go. Paste it there. Okay, so for the cluster name, we can use the variable app name. And if you'd like, you can also interpolate this one. You already know the steps, so if you'd like, you can do it. Cluster endpoint public access equal to true. I'm just going to leave that. Cluster add-ons, we can leave that as well. And then VPC ID, we're going to be using the output of this VPC module. And to do that, pretty simple, just module dot the resource name, which is VPC. Double check, it's going to be this one. So module dot VPC dot VPC ID. And for the subnets, it's going to be the same thing. Module.vpc, and then we're going to be using private subnets. For the control plane, we're going to be using the intra subnets. So it's going to be intra subnets. There you go. And then, so for the EKS managed node group defaults, this is just a list of the EC2 instance types that you want to use for your EKS cluster. And let's just put in T3 medium for now. EKS managed node groups. Let's change this name to something like var app name ng, which is short for node group. Instance type, let's just copy this out. So min, max, and desired size. You want at least 2 for a minimum because you want that HA or high availability, and max size of 10 instances. So that means it will scale up depending on the thresholds that you put in. It can be a memory threshold, it can be a CPU threshold. So for example, if the CPU is greater than 80%, then scale one more until it reaches 10. And then I'm going to add in one more block of code in here. Now this block of code is very important because this allows the volume of the managed node group to be encrypted by the KMS key that we created over here. Next is enable cluster creator admin permissions. Okay, that's true. Now this block of code here is if you have any roles or users that requires access to the EKS cluster, this is where you put it. But since this is just a sample exercise, I'm just gonna delete these ones. For the tagging environment, we've got a variable called environment as well. I'm gonna put that there, and Terraform is true. Now that the tags are done, let's add in the KMS bit. So by default, EKS module, it'll create its own KMS key, which we don't want. Create KMS key, and we're gonna set that to false. Lastly, I'm gonna add this input called cluster encryption config. What this is that if you create secrets in your EKS cluster, those secrets will be mapped to an EBS volume, and those EBS volumes will be encrypted by the module.kms that we just created. And that's all we got for this one. Let's save this. Okay, let's open the terminal. And let's navigate to Terraform folder. And then let's do another Terraform init. Okay, that's initialized. And then let's do a Terraform plan. See how many resources it's going to create. So it's going to create 37 resources for this EKS module. And lastly, let's do a Terraform apply, auto approve. And this should take a while, I think 15 to 20 minutes. Okay, finally apply complete. That took some time. Let's double check if the EKS cluster was indeed created. Yep, random app. There you go. And for us to access the EKS cluster via CLI, let's go back to Visual Studio Code. I'm just going to clear this up. Now the command to execute for our CLI to be able to communicate with the EKS cluster, it's going to be AWS EKS update kube config. Let's add in the name of the cluster, which is random app. And then the region would be US East 1. Okay, and let's try it out. Let's do kubectl get nodes. And these are the two EC2 instances in our managed node group. Now let's check out the namespaces. We've got several in here. And there you go. Now you have full access to your EKS cluster.